Let's start today's topic with a common experience. In winter, when we sit inside the house, we feel cold, and if we come out in front of sun rays, then we feel warm. Actually, this is the sensation of warm or cold. In our daily routine, we come across a number of objects, out of which some are hot, while other objects are cold. For example, when a frying pan kept on a burning gas stove, it becomes hot, but the handle of the pan is cold. Even among these hot objects, some objects may be hotter than the others. In the same manner, among the cold objects, some objects may be colder than the other. So, if I ask you how to decide the relative hotness and coldness of an object, then the first answer comes as simply by touching it. But our sense of touch is not enough in telling us whether an object is really hot or cold. Let's find out whether our sense of touch is reliable or not with the help of a simple activity. Take 3 small containers and label them as A, B and C. Put cold water in container A, hot water in container B and mix hot and cold water in container C. Dip your right hand in container A and left hand in container B for 2 to 3 minutes. After that, simultaneously dip both the hands in container C. Now, your right hand feels that the water is hot and your left hand feels that the water is cold. It means our sense of touch is actually not at all reliable. So the reliable measure of hotness and coldness of an object is called the temperature of an object. It is an only property that indicates which object is hot and which one is cold. A high temperature of a body indicates that it is very hot, whereas a low temperature of the object indicates that it is quite cold. For example, the temperature of boiling water is quite high, so boiling water appears to be very hot. On the other hand, the temperature of melting ice is quite low, so ice appears to be very cold on touch. Let's take a common example. When we keep a frying pan on a flame, it becomes hot because the heat passes from the flame to the utensil. And when the pan is removed from the fire, it slowly cools down because the heat is transferred from the pan to the surrounding. So, in both cases, heat flows from the hotter object to the colder object. In other words, we can say that heat flows from an object at the higher temperature to an object which is at lower temperature. This flow of heat is called transfer of heat. When the two objects attain the same temperature, then the flow of heat stops. It means there is no flow of heat if the two objects are at the same temperature. There are 3 ways through which heat can be transferred: conduction, convection, and radiation. When the heat is transferred from the hotter part of a material to its colder part without the movement of material as a whole is called conduction. In all solids, heat is transferred by the process of conduction. Have you noticed that when you put a cold metal spoon into your hot cup of tea, the teaspoon handle also warms up after a while? In this case, the tea is hot and the metal spoon is cold. When you put the metal spoon into the hot tea, some of the heat energy from the tea is transferred to the metal's particle. The metal particles start to vibrate faster and collide with their neighboring particles and transfer some of the heat energy to their neighboring particles. In this way, the heat is transferred to the other end. Keep a pot of water on a burner. Only the bottom of the pot touches the flames of the stove. But you will notice that all the water inside the pot, even the water which is not touching the flame, becomes warmer. Now, how does the energy transfer throughout the water in the pot? The transfer of energy is because of convection. In convection, heat is transferred from the hotter part to the colder part of the fluid by the movement of the particles. Convection occurs in liquid or gas. When we heat gas or liquid, the substance expands and the particles gain some energy and start to move faster and away from each other. Due to this movement of particles, energy is transferred from one area in the liquid to another. Have you ever wondered how the sun is able to warm us even though it is so far away? The energy is transferred from the sun to everything on the earth. The sun doesn't need to be touching the earth for the energy to be transferred. Also, there is space in between the earth and the sun. So the energy from the sun is able to warm us without the sun ever touching us. This transfer of energy is called radiation. It is totally different from conduction and convection, as it doesn't require objects to be touching each other or movement of particles. So the transfer of heat by radiation doesn't require any medium. It can take place whether any medium is present or not. In our day-to-day activities, we have seen many situations where heat is transferred by the process of radiation. For example, if we keep a hot utensil or a hot glass of milk away from the flame, it cools down after some time by transferring its heat to the surrounding by the process of radiation. The heating of a room by an open fireplace is another example. The flames, coals, hot bricks radiate heat directly to the objects present in the room and makes the room warm. So far we have learned that in solid, heat is transferred by conduction. In liquid and gases, heat is transferred by the process of convection. And in vacuum and free spaces, heat is transferred by the process of radiation. In this figure, you can see all three modes of heat transfer. When we place a metal rod close to the fire, it will become hot because metal is a solid and heat is transferred in solid by the process of conduction. And if you place your hands above the flame, you can feel the heat because the air around the flames become hot and rises up. In this case, the heat is transferred by the mode of convection. And you can still feel the warmth if you are far away from the fire because in this case, the heat is transferred by the process of radiation. Hope you enjoyed learning today. Please like, share and subscribe to my channel, and thanks for watching.